Have you ever really stopped and thought about the invisible magic that's packed into all the tech we carry around? Well, there's this unsung hero, this revolutionary material that has just quietly changed everything. From the way you charge your phone to, well, the entire way our world is connected, it's a pretty incredible story. And it starts with something you definitely use every single day.
Okay, just look at this. On the left, you've got that familiar, clunky old power brick we all know and tolerate. And on the right, it's modern replacement. It's tiny, it's sleek, but it's got the exact same amount of juice. I mean, we've all seen our gadgets pull off this incredible shrinking act, but how? How is that even possible?
That question is actually pretty simple, but the answer? Well, that's a whole fascinating journey into material science. See, it's not just about a cleverer design. It's about a fundamental change in the very stuff we use to build our world. So what is this secret ingredient? The answer is a material called gallium nitride, or GaN for short. This right here is what's making our technology smaller, faster, and way more efficient. So let's get properly introduced to this absolute game changer.
So what exactly is GaN? Well, at its heart, it's a man-made semiconductor crystal, and it is incredibly tough and super stable. That's what makes it perfect for handling really high-power, high-frequency jobs, things that are way beyond the limits of good old silicon, which, has been the king of electronics for more than half a century.
And here it is. This is the source of all its power. You're looking at the Wurtzite crystal structure of gallium nitride. That super tight, super strong bond between the gallium and nitrogen atoms is what gives GaN all of its extraordinary abilities. It's literally the atomic blueprint for a revolution.
So, what are these extraordinary abilities? I honestly like to think of them as GaN's superpowers. So let's break down exactly why this material is such a huge leap forward, especially when you put it side by side with the old champ, silicon.
Okay, this is where it gets really crazy. Look at the performance gap here. Silicon, it's been the reliable workhorse forever, but it starts to struggle at around 150 degrees Celsius. GaN, it can handle a scorching 400 degrees Celsius and much higher voltages. That kind of toughness means you can push it way harder without it failing, which lets engineers build smaller, more powerful stuff that doesn't need all those big, bulky fans and heat sinks.
Now, the big secret to all this performance comes down to one key property. It's called the band gap. The easiest way to think of it is like the width of a river that electricity has to jump across. For GaN, that river is about 3.4 electron volts wide, which is a lot wider than silicon's. But what does a wider river actually mean for your phone charger?
Well, sticking with our river idea, having a wider band gap means you can send a much bigger, faster boat, in this case, more electricity, across without it spilling over the sides. That spillage, that's wasted energy, and wasted energy creates heat. Because GaN is so good at keeping all that energy contained, it stays much cooler. And when your components stay cool, you can pack them way closer together. And that is how you get those tiny, powerful devices we saw at the start.
But look, this isn't just theory or something happening in a lab. GaN's impact is already all around us, and it goes way beyond just making smaller chargers. Let's do a quick run-through of how this material is already shaping the world we live in. All right, first up, the light that we see every day. For decades, scientists could make red and green LEDs, no problem. But a true, bright, efficient blue light, that was like the holy grail. Turns out, GaN was the answer. See, its unique properties made it possible to create those bright blue LEDs, which was the final piece of the color puzzle. With red, green, and blue, you can make any color you want, including that pure, energy-sipping white light that's in our light bulbs. And that same tech, when it was refined, became the little violet laser that reads the information off of Blu-ray discs. Pretty cool, right? But it doesn't stop with light. GaN's ability to handle all that power and those high frequencies is totally revolutionizing how we communicate. For example, the huge rollout of 5G? That's really only possible because GaN transistors can amplify signals with enough power and efficiency to give us those crazy fast speeds. And that same toughness, that resistance to radiation, makes it perfect for the brutal environment of space, where it's now the go-to material for building communication satellites that are made to last. So this incredible combination of power and durability, well, it naturally caught the eye of the defense industry. When you're talking about the most advanced radar systems, GaN is the new gold standard. And just look at how fast this all happened. It wasn't a slow burn. What started with some early systems back in 2010 quickly became the industry standard. By just a few years later, All the major players, Lockheed Martin, Saab, were rolling out these advanced tactical radars built on GaN. This wasn't just an upgrade, it was a total strategic shift towards systems that can see farther and react faster, all thanks to this one material.
Now, when you see GaN at the heart of all this high-tech gear, it's pretty easy to think it's some brand new invention. But the truth is, its journey from being a lab curiosity to a world-changing material was actually a really long and difficult one. It goes back decades.
It was first created way back in 1938, but for a full 50 years, it was basically a scientific oddity. It was this promising material that was just too hard to work with. The whole field was stuck. Until a massive breakthrough in 1989. That discovery of something called p-type GaN was the key that unlocked absolutely everything. It finally let scientists build electronic components with it. And after that, as you can see, progress just exploded, leading to the first real-world transistors hitting the market in 2010.
So, that brings us to today. GaN is already a force to be reckoned with, but honestly, we are just scratching the surface of what it can do. So, where is this wonder material going next?
Well, on the absolute tiniest scale, scientists are creating GaN nanowires, which could lead to circuits that are almost unimaginably small and powerful. They're also exploring this wild idea called spintronics, where they use not just an electron's charge, but its magnetic spin to process data. That could be a whole new era of computing. And on the biggest scale, just imagine applying GaN's insane efficiency to our national power grids. We could cut energy waste dramatically. That's a huge step forward for green tech.
If you take away just one thing today, let it be this simple fact. The core superpower of gallium nitride is its incredible efficiency. It means less waste, less heat, and more performance. It is the engine driving both miniaturization and power.
From our chargers to our satellites, gallium nitride is this powerful reminder that the next great leap forward, it often comes from a breakthrough in the fundamental stuff we build with. It really makes you wonder, doesn't it? What's the next GaN? What new material is sitting in a lab right now, just waiting to define the world of tomorrow?